Welcome again. Welcome you all in the second lecture of Engineering Mathematics 1 MTL 1025. In this lecture, we will going the following topics. What are the general derivatives? What is partial derivatives? What is the geometrical interpretation of the partial derivative? And one or two simple examples of the partial derivative. Right? First, we will discuss what is general derivative. In general derivative, we use how quickly or slowly a function varies with respect to changing variables or with respect to independent variables. With respect to independent variables. That is, a function how quickly or slowly changing its behavior with respect to change in the independent variable. For the two-dimensional continuous curve, what is derivative? Derivative can be thought as representing the instantaneous slope with respect to changing variable. For example, what is df by dx if y is equal to function of x, y is dependent variable and x is independent variable, right? Then what is df by dx? Df by dx is equal to limit delta x tending to 0 f of x plus delta x minus f of x divided by delta x, right? This is definition of general derivative which we already studied in class 12th, and this derivative is known as first order derivative, right? And this definition is limiting process. Now, what is second order derivative? Second order derivative of function y is equal to fx is defined as limit delta x tending to 0 f dash x plus delta x minus f dash x delta x, right? And nth order derivative is defined as limit delta x tending to 0 n minus 1th derivative of f at x plus delta x minus n minus 1th derivative of f at x divided by delta x. What is partial derivative, right? Our course start from here. What is partial derivative? The first order partial derivative, we use partial derivative when our function f is two or more than two variables. Suppose if function is fxy and we want to differentiate this function. In this case, partial derivative will occur. F is function of xyz, right? In this case, partial derivative will occur. Means partial derivative will occur where function is two or more than two dependent variables, right? If fxy is a function of two dependent variables x and y, then we will define the first order derivative with respect to both independent variables, that is x and y also. What is first order partial derivative of f with respect to x? That is dou f by dou x. And first order partial derivative of f with respect to y, dou f and dou y. What is dou f upon dou x? if you differentiating partially function f, f, sorry, differentiating partially function f with respect to x, that is dou f dou x, then treating all other variables as constant, right? Suppose f is function of two variables x and y, and we want to evaluate partial derivative of f with respect to independent variable x, then we treat y as a constant. What is mathematical definition of dou f by dou x? Dou f by dou x is, remember, you are differentiating this function with respect to x, then change occurs only in direction of x, right? Y remains same. Y is no change in y since we are treating y as a constant. Then dou f by dou x is limit h tending to 0, f of x plus h means change in x only. Y remains as it is. F of x plus hy minus fxy divided by h, right? If this limit exists, then this is partial derivative of f with respect to x. Similarly, partial derivative of f with respect to y, that is dou f upon dou y, limit k tending to 0. In this case, x is constant and y is variable. F of x y plus k minus fxy divided by k. If this limit exists, then it is known as partial derivative of f with respect to y. See this diagram. This is very useful diagram throughout the course in partial derivative when we discuss partial derivative, a total derivative, right? Suppose f is function of x and y, right? Then see, this is f. Now one branch gives the partial derivative of f with respect to x, that is dou by dou x of f, dou f by dou x, and another branch gives the partial derivative of f with respect to y, right? That is dou f by dou y, right? Again, if we want to evaluate second order derivative, then differentiate first order derivative partially with respect to x and y again, right? Then this branch is second order partial derivative of f with respect to x, right? Then dou by dou x of dou f by dou x, that is dou 2f by dou x2. Similarly, partial derivative of dou f by dou x with respect to y, this branch, dou by dou y, dou f by dou x, that is dou 2f dou y dou x, right? Similarly, other derivatives also, this branch gives us dou 2f dou x dou y, and this branch gives us dou 2f dou y2. Now, one natural question arises whether these two derivatives are equal, right? If both are continuous, then these two derivatives are equal, right? Otherwise, we can't say. Right? This is the second order partial derivative of f. Now, what is the meaning of partial derivative? right? In first lecture, we already discussed what is the surface, right? This green part represent xy plane. And in first lecture, we already discussed for any ordered pair xy, one value of z, right? Corresponding to this xy, we find z. Now, what is this point? This point is represented as x, y, and z in 3 dimensions. And this blue thing, the blue part that you are seeing, this one is z equal to f of xy, right? Then, what is the meaning of del f? See, del f by del x is, sorry, the meaning of dou f by dou x is slope of f, right? Remember that we are calculating dou f by dou x, means treating y as a constant. Say y is equal to b. Dou f upon dou x is equal to slope of f, x, and b, right? What is fxb? Putting y is equal to b, right? And x is a variable. X is any value, right, on x-axis, and y is always b, right? Y is, sorry, this one is b. Y is always b, right? Then fxb is this curve that you are seeing with orange line. This one. This is fxb. What is dou f by dou x? You draw a tangent line at any point of this curve fxb, right? Remember that fxb is function of one variable. fxb is function of one variable. This fxb is function of one variable. Now, draw a tangent line at any point of this curve. Let this is the point where we draw the tangent. Tangent is drawn by the green line, right? Then the slope of this fxb at this point is known as dou f by dou x, right? Similarly, we can define the meaning of dou f by dou y, treating x as constant and make y as variable, right? See. Let us see, x is equal to c, x is fixed, right? And y is changing. Then this curve fxy, x is fixed, x is c, and y is changing, right? Then this orange line gives z equal to f of cy, right? Now, at any point, at any y, right? If x is equal to c, then y can be any point, right? Then dou f by dou y is the slope of, draw a tangent line at any point, say point is d, y is equal to d. Now, then at this point CD, we draw a tangent line. Then dou f by dou y is the slope of this straight line represented by the green line, right? This is slope of fcy, right? This is the meaning of partial derivative of del f, dou f, dou x, and dou f, dou y. Now, what is partial derivative? Dou f by dou x and dou f by dou y of a simple function. fxy is equal to, right? We use partial derivative to determine the rate of change of f in x direction and in y direction, right? At point 1, 2. What is that? Dou f by dou x. Remember, dou f by dou x. Dou f by dou x is nothing but it is a derivative treating y as a constant, right? Then derivative of x square is 2x minus derivative of x minus y square. Y square is constant, so y square is as it is. Derivative of x is 1 into 1 plus derivative of y cube is 0, right? This is 2x minus y square. A partial derivative of f with respect to x. Similarly, dou f upon dou y is equal to, what is derivative of x square? 0 minus, what is derivative of x y square, right? Derivative of y square is 2y, x is constant, then 2xy. Derivative of y cube, 3y square, right? This partial derivative of f with respect to y, right? Dou f by dou x is 2x minus y square, and then we put dou f by dou y at 1, 2 is equal to, means x equal to 1 and y equal to 2, minus 2 into 1 into 2 plus 3 into 2 into 2, right? This is equal to minus 4 plus 12 is equal to 8. Dou f by dou y at 1, 2 is equal to 8, right? In next lecture, we will discuss in detail partial derivative of some complex function, and we will prove some identity also. Okay, thank you.